1. Introduction to Solid Modeling. This presentation is going to be mostly about the making of solid models. I'll talk about the process and create some mechanical models. 3D models are used in many ways. The movies and video game people use them. Architects use them to demonstrate proposed buildings and landscapes. Engineers use them as designs of new devices and vehicles. Architectural solid model of a school building. Later on, near the end of the presentation, I'll construct the solid model of the school building that you are now viewing. Student solid model assemblies. Here are a couple of solid model assemblies created by some of my students. The detailed drawings from which these models were made are from the technical drawing book by Giesecke and others. Students' mechanical solid parts. These solid model parts were also made by my students here at Wentworth. Many of the students have had little or no experience with any kind of a CAD program before coming here. Many of them show enthusiasm and seem to have fun learning AutoCAD, especially when they are taught how to make solid models during the first week of the course. However, in order to make drawings both 2D and 3D, a student eventually has to learn basic concepts. He has to learn about layers, for every object has to have a layer. With layers you control color, visibility, and whether the layers are on, off, or frozen. Blocks are a useful tool also. Blocks are just groups of objects. A sample block might be a table or a chair. You can save that block outside the drawing file with its own .dwg designation. Blocks can then be inserted into any drawing as often as desired. Scale factor too is very important. You might want to draw a football field and need a scale of 1 to 100, or a map and need a scale of 1 to 500. You might draw something like a laptop or a piece of furniture, and your scale might be 1 to 1 or 1/4. You might want to specify on a drawing different units such as decimal, fractional, or architectural units. Hopefully by the end of my course, the freshman students have learned all that and more. Extruding objects. The extrude command is the basic tool used to create 3D solids. Extrude creates solids from closed objects such as polygons, closed splines, rectangles, circles, ellipses, and regions. When used for extrusion, these objects are called profiles. You can extrude a profile in either a positive or negative direction. Extrusions can have either a positive or negative taper and can be extruded along a straight or curved path. This video clip will show the extrusions of various objects I selected, all in red: a closed spline, a closed polyline, a donut, an ellipse, and a region. I type 1.5 to specify the height of the extrusion and pressed Enter to accept the default value of 0 for the taper angle. The selected profiles are extruded 1.5 units straight up. Negative extrusion, 0 taper. Next, I repeated the extrude command and picked the blue polygon and blue circle. I typed -2 to specify an extrusion height of -2 units and accepted the default 0 taper angle. You will notice that these objects were extruded in a negative or down direction. Extrusion positive taper. At the top of the screen I drew a magenta colored polygon and typed 1 to specify an extrusion height of 1 unit and 10 to specify a taper angle of 10 degrees. You can see that the taper on the object is clearly visible. Extrusion negative taper. The green circle in the lower left corner will be extruded to a height of 0.5 and given a taper angle of -12 degrees. Notice that the taper angle is going outward. Extrusion perpendicular to a plane. In this last example, a black tilted rectangle is shown. It was extruded to a height of 2 units. You will note that the extrusion is perpendicular to the plane of the profile. Extruding